In this video, we are going to look at some examples where we are going to try to find intervals of increasing and decreasing for some different functions. And so let's look at this first example where k of x is equal to x minus 1 squared times x plus 3. If we were to take the derivative there, you could either expand that and then take your derivative, or you can take your derivative using a chain rule and product rule. If you take your derivative here, you will get a derivative of 3x squared plus 2x minus 5. And what are we going to do with that? We're going to find critical numbers, so we set that derivative equal to 0. You might recognize how that factors, maybe you don't. If you don't, you could use the quadratic equation, quadratic formula, and you will find values of x of negative 5/3 and 1. Okay, so we found these critical numbers. We should also identify, are there any points where the function does not exist, anything where any values outside of the domain of this function. And this function is a polynomial, so it exists everywhere, so there are no points of discontinuity. And so now we are going to create a sign chart. Okay, so over here we are going to do a sign chart. We will go from negative infinity up to negative 5/3. We will go from negative 5/3 up to 1, and then from 1 to infinity. And we're doing a sign chart for our derivative. So here we want to plug in any number that is smaller than negative 5/3. And we're plugging that into the derivative. So plug something smaller than negative 5/3 in here. So like negative 10. 3 times negative 10 squared, that would be like 300. Plus 2 times negative 10, so 300 minus 20 minus 5. I don't know what value that is, but I know it's positive. So we'd get a positive value if we plug in something smaller than negative 5/3. Plug in something between negative 5/3 and 1. So a nice test point might be 0. If you plug in 0 for your x, you'll get negative 5, so you get a negative value. And plug in something larger than 1. So, I don't know, maybe I would choose 10 again. 3 times 10 squared is like 300, plus 20 minus 5. That's going to be some large positive number. All I care about is the sign, but we have a positive value. So what does that tell us? Well, that tells us k is increasing on negative infinity up to negative 5/3, along with 1 to infinity, and k is decreasing on negative 5/3 up to 1. So it was decreasing when our derivative was negative, and it was increasing where our derivative was positive. Great. Let's look at a second example. So our second example here, we have f of x equals x to the 1/3 plus 1. We will take our derivative. So we have 1/3 x to the negative 2/3. Bring the power down, subtract 1 from the power. So this is the same as 1 over 3 times the cube root of x squared. What are the critical numbers for this? Well, there's not going to be anywhere that the derivative is equal to 0, because that numerator is never going to be equal to 0. But there is a spot where the derivative does not exist. Right? So when our denominator is equal to 0, that's going to be bad news. And that's going to happen exactly when x is 0. So f prime does not exist when x is equal to 0. So let's do a sign chart here. We're going to go from negative infinity up to 0. And then we'll go from 0 to infinity. And, up here, I labeled that as f. I'm going to go back and change that to k. I apologize. All right, back to the problem at hand. We are doing a sign chart for our derivative here. So plug in a value smaller than 0. So plug in a negative value. So like negative 10. Negative 10 squared is 100. We take the cube root of 100. That's still positive. 3 times that positive value is still positive. No matter what you do there, you get a positive value. And when you plug in something bigger than 0, you also get a positive value. So what does this tell us? Well, this tells us that f is increasing on negative infinity up to 0, along with 0 to infinity. And it is not decreasing anywhere. And that is what we have for that second example. Come back for our next video and we will look at our next examples. We will see you there.